All right, so today we're going to continue learning doing integration. So I know you already have this rule number 4 over here that we do, but we haven't done much any example on here. So today we're going to do that. So that will be integration with respect to trigonometric function, integration of trigonometric function. That is the topic for today. So the topic for today is integration of trigonometric function. Okay. So these are all the rules that I think you might be needing as we progress on solving this problem. So just start with the simple basic one, okay? Let's just do with this with a simple basic one. If what problem number? Example number 31. Now 31, right? So example number 31. So if you have an integral of something, integral of a sine of x dx, what answer is that? So if you go to rule number 4, integral of sine of x is just simply negative, negative,
Um,
negative,
Native
negative,
cosine.
negative cosine of x plus c. Okay, that would be negative cosine of x plus c. Okay, that is a very simple example, right? Now what happened? Let's do another a little bit more complex one. Let's say if I have an integral of, say, 3 times cosine of 2x dx. Okay, how will I solve this problem? Okay, so the easiest way to solve this problem is to assign the u du scenario. Okay, integral with u substitution. In this case, we let u to be equal to 2x. Therefore, our du is equal to 2 dx, or du over 2 is just simply equals to dx. Right? So you substitute it back. So integral of 3 cosine of u times your dx is simply du over 2. So 3 over 2 is just simply a constant. So you take it out. Integral of cos of u times du. But you know that the integral of cosine function is what? It's simply here.
Sine of
Sine,
x
sine,
plus c.
sine, sine plus. So that's for the answer for here is simply integral of cosine is simply sine of u plus c. Right? Okay, don't forget this rule over here. Very important rule. All right. So therefore, all you need to do is resubstitute it back. So 3 over 2 sine of u is equal to 2x plus c. Right? That's simpler enough. Yeah, that's easy enough. Okay. What about this? Let's say I have problem 33. So integral of, say, integral of tangent of x dx. This is very simple, right? So what is the integral of tangent of x and dx? Huh?
Um,
Have you done this
s-
already? I don't think we have. No. But
what?
if you look at this property over here, you don't have an integral of tangent x, integral of tangent. The property, you don't see any integral of tangent, right? But you do know that the tangent is simply equals to the sine of x over cosine of x dx. You know that, right? That's correct. So all you need
Yes,
simply
sure.
do is you just do u substitution. Let u be equal to what? U be equal
To
to? No, it has to be
sine.
something at the sine x or cos x. So you need to put cos of x. So du should be, what is derivative of cosine of x? That will be negative sine of x dx.
Cos x.
So du over negative sine of x is simply equals to dx. So you just substitute it back over here. Integral of, so, okay, so you know that u is equals to cos of x. So sine of x over u is over u times your d of x is simply negative du over sine of x. right? And in this case, you can just simply cancel out the sine of x and just take out the negative on the other side. You have negative 1 of du over u. Now you apply the rule number 2. Here, you apply rule number 2. Okay, and then you apply rule number 2 over here. So if you notice, rule number 2 is what? If you have integral, the derivative on the numerator and that's so integral of dx over x is just simply ln of x plus c. In the same manner, integral of du over u, that will just simply be ln of u plus c.
C.
So, and then you just simply ln of u is simply cosine of x plus c, and that is your answer, okay? So, yeah, don't forget to box your answers like this. All right, so that's just simply the answer. Okay, what about problem number 34? Okay, so if I have, let's say the integral of sine of x times cosine of x dx. Okay, now you also know about trigonometric identity, right? So you know trigonometric identity. So there are several trigonometric, if you go back to your pre-calculus, so there is a very important, there is a bunch of trigonometric identity that you need to know as well. Okay, so for example, these identities, okay? So these are some identities that I need you to remember as well when doing this. All right, so in trigonometric identities, you have a bunch of different identities, right? You have the quotient identities, you have the reciprocal identities, you have half angle, you have a sum to product formula, you have double angle formula, yeah, double angle formula, co-function identities, triple angle formulas, and such, Pythagorean identities. So all of these identities are important, and you don't have to memorize this. You can just write it down, bring it to class when you have an exam. But the point here is, in order to find a trigonometric integral of trigonometric function like this, you need to know this identity. So you need to have it with you, right? So because the when you multiply sine and cosine, which angle is so for example, if you see here, if you go to sine 2x, where is sine 2x? So if you look at the double angle identity, what do you see? If you look at double angle identities, this identity over here, what is it? That's a double angle identity, right? So double angle is written as what? It's written as sine of 2a is equal
2A,
to
2 sine of A and cos
sine of
of A.
a cosine of a. Now I can also rewrite this as I can also rewrite a sine of 2a over 2 is equal to sine of a cosine of a. This is correct, Los Galep? Yeah,
Yes.
this is the same expression. So now that you know this trigonometric identity, so instead of writing this sine a cosine of a, I'm going to rewrite this function as integral of sine of 2x, or sine of x over, sine of 2x over 2 dx. I'm just going to rewrite it like this. It's the same thing, right? I'm uh, using trig identity. You get this, right? So you can take out simply 1 over 2 integral of sine of 2x dx. So now you can do that. Now you can solve for. Now you can let u to be equal to 2x and du to be 2 dx, where du over 2 is simply equals to dx. Now you can substitute this integral of sine of u. What's our your dx is simply du over 2. So you just bring it out. So take 2 out. So that will be 1 over 4 integral of sine of u times du. Now that you know this, integral of sine of u, you know from this rule number 4, right? Integral of the sine is what? Integral of sine is simply negative cosine. So integral of sine is simply negative of cosine. So all you need to do is 1 over 4. Okay, 1 over 4, or you put the negative over here, cosine of u plus c. But you know your u to be equal to 2x. That will cosine of 2x plus c. And this is your answer. Okay? Any questions?
None,
Any?
teacher.
All right. So, okay, what about this? Number 35. So integral of, let's say, sine square of x dx. Sine square of x dx. Okay. So how do you solve this? You have to figure out a way in which you can easily solve this, yeah? Now, the way I am going to solve this is I am going to use the different identities. I can use the Pythagorean identities, or I can just simply use, yeah. So sine square of x is simply equal to what? Or I can just use cos of double angle identities, yeah? So for example, if I look here, so cos of 2a is equal to this, also equals to this, also equals to this, also equals to this. So there's three different ones, right? But I have a sine square here, so I need to look for the thing that has a sine square. So cos of 2a is also equal to 1 or minus sine square of a, right? That I know that. Mhm. Or you simply just do, or you can just simply do like this. If you can just simply let u be equal to sine of x, your du will just be simply what? Negative cosine of x
Cosine of x.
dx. So your du over negative cosine of x is just simply equal to dx. Let's just use this for now. See if it works. Okay, if I do the integral of this, right, what happens? So sine, that will be u squared times of my dx is simply du or minus cosine of x dx. Now that's a bit, that will be a bit difficult now, right? Because I also have a denominator. I cannot just simply take it out of the, I cannot just simply take it out of the integral, because this is a variable, right? You cannot do this. Okay, so you have to look for different methods. Okay, so let's look for different methods. So this is not working. All right. So in order to do this, what about let's use a Pythagorean? Let's use some identities over here. What identities is best to use? So for example, if you use Pythagorean identities, you know that sine square of angle is plus this is equal to this. All right, you do know that, right? Now, if you know this, then all right. So where's my hand? Is on. So this thing you don't need anymore. So let's just delete this stuff. All right. So what identity? So let's suppose we use the double angle identity. Let's say we use Pythagorean identities. Okay. So Pythagorean identity says sine square of the theta plus cosine of square of the angle is equals to 1. Okay. If we move this to the other side, sine of square is equals to 1 minus cosine square of the angle. What if we use this one? Okay. Will this get me a different answer or the same answer? So that will be equal to sine squared is just simply 1 minus cosine square of x dx. Okay, that will just still give me the same problem. I can substitute this dx, 1 dx minus integral of cos square x dx. That will just give me the same problem as earlier when I tried to integrate this. This one will give you the same problem as earlier, right? This one is no problem, that's easy, but this one just gives me a the same problem. So that doesn't work as well. Okay, so how do you best solve this? Oh, so what about, let's use the one over down here. You know that cos of 2a is equal to 1 minus sine square of a. So you know that, suppose, this is the one double angle formula. So cos of 2a is equal to 1 minus sine square of a. So I can just move it around. So sine square of a is just simply equal to 1 minus cos of 2a, for example. Okay, now let's do this. Instead of doing that, so I can just substitute sine the square root of sine of square of x is just simply equal to 1 minus cos of 2a, cos of 2x dx. Now, will that work? Probably. So let me just split it again. So integral of 1 dx minus integral of cos of 2x dx. Now, this becomes easier. For this term, you just integrate directly. The integral of 1 is just simply x minus. Now, in this one, in this case, this is where the trick comes from. If you let u be equal to 2x, your du becomes 2 dx, right? So you can just substitute cos of 2x or 2 cos of u. So du over 2 is equal to dx. Okay, so dx is simply du over 2. So you can just take out the 1 over 2 integral of cos of u du. So now you know the integral of cos of u, you already know. Integral of cos of u is what? Sine of u, right? It's just from this rule number 4 over here. Sine of u. So that's easy. Okay, up to this point, then you just simply x minus 1 over 2 sine of u plus c. But you know u is equal to 2x, so you just have to rewrite sine of 2x plus c, and this is your answer. So it's a matter of how do you intelligently, okay? So a derivative of trigonometric function is basically how do you intelligently use the tools that you have available in order to solve for your problems. That is what trigonometric identity is. Yeah. So how do you intelligently use the tools at your disposal to solve the problems? That is what trigonometry, the integral here. So it's just a matter of all of these you already have a tools in your disposal. Yeah, everything here you already learned about it, correct? You already learned about trigonometric identities in pre-calculus. Logically.
Yes, teacher.
Okay, so it's just a matter of how to use a tools at your disposal to solve for a particular problem. And sometimes when you use different tool, you might end up with the different answer. Okay, you might end up with different final answer. I mean, technically the same, but the formula, different tools might end up a different answer. But that's the problem over there. All right. Any questions so far? ¿Hay preguntas, Roma?
None so far, teacher.
All right, let's continue. So number 36. So suppose you have an integral of, let's say, secant square of x dx. Right, so let's just go back to the rule number 4. Do we have anything secant square of x? Yeah, directly. You notice that integral of secant square of x is simply the tangent of x plus c. That's very simple, right? So that is just equals to tangent of x plus c. That's not very hard at all. All right. Now, what about this one? What about integral of secant of x times tangent of x dx? How do you solve this? So you know that you recognize, so let's go back to rule number 4. Can we just directly use rule number 4 to solve for this problem? Yes, we
No.
can.
Oh, yeah.
Here, at the bottom over there, sec of x times tangent of x dx is simply,
Second of x plus c.
it's just simply sec of x plus c. That's your answer. Very simple, yeah, very quick, right away. And you just hope that in the exam it's simple as that, but I don't think that will be the case. All right? All right. Let's say I do another example, 38. So suppose I have an integral of cos of cube of x dx. Suppose this, I want to integrate this function, cos 3 of x dx. Okay, so how will one approach solving this problem? Huh? Now you do know you can split this up. You can split this into cos of x times cos square of x dx. Now expression, are these two things the same or different? Expression ruannya
Different.
anesan kah lanesan? Are these equal or not?
Different.
Why different? Why?
Um, because there's what was it, two cosines at least, so
No, it's a two cosine, but the expression is the same. It's the same expression. Why?
uh,
Saya mati nih, dan hanesan deh. Saya mati nih. ADM ya? ADM ya? Expression ruannya hanesan
Ya,
kah lanesan?
mm,
So if you have a cosine of something, cosine of x times cosine of x, what you get? Ito sana. Huh? When you have two cosine multiplied to each other, what you get? What do you get?
Cosine square.
Yes, cosine square. Y square of x. Tama sa may square. Tambah hene satu, hene satu. Ito lahat kira los galay. Sekarang cosine square of x multiplied by cosine square of x. Kelihatan saya. Ah, cosine to the fourth of x. Los galay?
to the fourth, yes.
Neve,
Yes,
letemos
sir.
anesa. O fahet dia, cosine of 3 of x, o fahet fali cosine of x multiplied by cosine square of x. Neve, bahiro multiplique suro, neve man suro, hetan fali? Cosine 3 of x, los galay.
yes, true.
So also this is the same expression, right? Right. So now that you know this is the same expression, let's just bring it back down over here. All right, so now you can replace using the trigonometric identities over here. Just always carry this with you. Okay, so you know that using trigonometric Pythagorean identities, you know that this one, sine squared plus cosine squared is equal to 1. So you know that sine square of theta plus cosine square of theta is equal to 1. So you can just bring this. So cosine square of theta is simply equal to 1 minus sine square of theta. Right? So, and then you just substitute this. So integral of cosine of x times 1 minus sine square of x dx. You already know this, right? So now that you already have this, all you need to simply do is what? You do let's let u be equal to sine of x, du be equal to what? What's the derivative of sine of x?
Cosine of x.
Okay, that will be cosine of x dx, right? Over dx like this. So you just so dx is simply du over cosine of x. Was it like? So then you just substitute this. So integral of cosine of x. So let me just bring this to the other side a little bit. So like this. So integral of cosine of x, that will be 1 minus what? 1 minus? 1 minus what? Say Martin.
Sine of
No, you already substitute sine by u here. So that will be u squared.
u square up.
And then dx is simply du over cosine of x. Conveniently, this cosine of x just cancels out. All you're left with is integral of 1 minus u squared du. Right? Then you can just integral of 1 du minus integral of u squared du. That's simple. So integral of du is simply just u minus, what is integral of u squared? That will just simply be u squared over 2 plus, that's it, right? U squared over 2 plus c. And then you just substitute back the u equals to the sine of x. Just put it back where it was. So sine of x minus sine square of x over 2 plus c. And this is your answer. Oh no, sorry, I forgot. This is wrong. Integral of u squared. Salah. U minus, what is integral of u squared? Basic u to the u to the 3 over 3. Lost ka lang. Basic integral ne. Lost ka lang.
Yes, sure.
Lost up plus c. And then you just
Yes.
substitute. So u is just simply sine of x minus sine cube of x over 3 plus c. And this is your final answer. All right. Any other questions?
None, teacher.
All right. So that is integral of trigonometric functions. Okay, let's do some integral of natural logarithmics. I don't know if I have a prepared here. All right, so let's do integral of natural logarithmic functions. Yeah. That's it, better. All right, so you know already that from rule number what? Yeah, rule number 2. This rule number 2 is very, very important, actually. Rule number 2. So you know that from rule number 2, when you have a derivative that is on the top and the thing is on the bottom, and then you just take the ln of that. So don't forget that. So now we can do more example on this different types. The derivative of in the form of derivative of integral. Sorry, integral of 1 over ax plus b dx. Okay, so and this is the form. This is the general form that we are trying to solve over here. So you know that when dx at the top, so let's just do some examples so you understand it better. Right, so let's bring it down over here. Let's also bring rule number 2 down here so you understand. So that will be example number 39. Okay, so 39. So for example, you have a, let's say if I have an integral of 1 over 2x plus 3 dx. So technically speaking, right? Technically speaking, I can also rewrite, it's the same thing as written as, it's the same thing as written as dx over 2x plus 3. So what do you notice here? When you take the derivative of the denominator, what do you get? When you take the derivative of 2x plus 3, ini ada taruhnya saya dah.
2
2 dx, right? It's just simply 2
3x.
dx. So,
Yes.
and you also have a dx on the numerator. So you say if you have x at the bottom and you dx at the top, and that's very good. So that's why you take ln, let u be equal to 2x plus 3, and your du is simply what? 2 dx, right? Or du over dx, yeah? Or derivative of u with respect to dx is simply 2. Logically? So therefore, your
Yes.
dx is simply equal to du over 2. And then you can just substitute integral of dx is equal to what? Dx is equal to du over 2 over 2x over 3 is just simply u, right? And then you can just take out this 2 over there. You have 1 over 2 integral of du over u. As simple as that, right? Now that you already have du over u over here, this one and this one is the same thing, right? So this thing and this thing is the same thing. That's good. So all you need to know is in 1/2 of what? The answer integral of du over u is what? The integral of du over u
Uh,
is rule number 2.
du over 2.
No, rule number 2. Look at rule number 2. Integral of du over u is simply ln of
ln of 2 plus
ln of
c.
u.
Oh, u.
ln of
Oh,
u plus c.
c.
Okay, so therefore, and then you just substitute u is just simply 2x plus 3 plus c. Okay, you need to practice, yeah, okay? You need to practice all of this.
Yes, true.
Okay, what about this? Let's suppose I have integral of 1 minus 5 minus 3x dx. Okay, let u be equal to what? 5 minus 3x. Therefore, my du over dx is simply what? Huh?
3 over du.
Negative 3.
Oh, negative.
So dx is simply negative du over 3, yeah? Yes. So integral of 1 over u dx is simply negative du over 3. So you can take out negative 1 over 3 outside. All you have is du over u, right? Now it's the same. Du over u is simply what? What is the integral of du over u? ln of u plus
u plus c.
And then you just substitute back ln of u. ln of u is simply 5 minus 3x plus c. Okay? Okay, what about this one? Let's do 41. What about integral of 4 over 7x plus 1 dx? How do you solve this problem? How do you solve this problem? We use u substitution. What is u appropriate here? What can we use for u to solve this problem?
7 7x
Yes, u is equal to 7x plus 1.
plus 1.
So du is equal du over dx is simply equal to
7.
7.
just simply 7. So therefore your dx is simply equal to du over 7, yeah? So just change this in multiplicable malade murade in posisi, that's the same thing. So you can just substitute this. So 4 over 1. What is 7x plus 1? 7x plus 1 is simply equal to
E.
u,
U.
right? Because we already assigned it here. Does that?
Yes, sure.
Now you also have so dx is equal to
du over 7.
du over 7. Okay, so now you just take out 4 and 7. So 4 over 7 is equal to du over u. So now integral of du over u, you know that already, which is just simply equal to
ln
Or
ln of u
ln
plus
of
c.
u plus c.
And then your u is what? 7x plus u was 7x plus 1 plus c. Okay.
C.
And what about another one? Let's do 42. I'm giving you a lot of examples over here, right? So practice, practice this until you dilurotak. Yeah, 1 over 1/2 of x minus 4 dx. All right. Ito na yung following sa. Well, in my case, how I can simplify it? How the denominator ne how I can rewrite my denominator? Yeah, ne para simplify it. Denominator. Okay, so 1 over 2x minus 4 ne habel hakkerek fila fali ano sa nabe? Habel hakkerek fali? X minus 8 divided by 2. Ne ano sa ngale? Los gale. X minus 8 divided by 2. Ne ano sa gale? Okay, guys, ano sa gale?
Anesan.
Sunday. So I can just rewrite my denominator. So that will just be 1 over x minus 8 over 2 dx. Vabbè, 2 nene habele multiplica fila fali. Dx ito nene habele hakkerek fila fali. 1 over 1 kali te fali 2 per x minus 8 kan sana lo salai dx. Hamura ti hauninia be divisão ito nene hamura fali multiplicação então troca te fali helate just flip it. Lo salai. So I will get integral of 2
2
1 over x minus 8 dx.
x 8.
And now you can let u be equal to x minus 8. What is du over dx?
It's, just
X. 6.
x.
What? No. Derivative of
Uh,
u over x is just simply what? What is derivative of just x? Just 1.
1.
One.
1. Yeah, 1.
Okay, so dx is just simply dx equals to du. So you just replace 2 integral of 1 over what? 1 over u times dx equals to du. Right? So now it's just, you can rewrite this as du over u. You know that du over u is simply equal to ln of u
U
plus
plus
c.
c.
And then you know that uu is simply x minus
6
8
minus 8.
plus c. Okay, so that is an example.
Previous yang sana.
¿Tienes preguntas, Roma?
None,
None.
teacher.
All right, 43. Maybe generalmente, yeah. So generalmente bahira mak so generally bahira imi ihabe problema dan sane if you have an integral of 1 over ax plus b e dx, imi ni resposta ni say 1 over a times ln of ax plus b plus the constant of integration. So that's simply the general formula for that. Okay. So we have rule number, what rule was that? Do we already give you this rule? Nope, not yet. Not yet. Okay, let's call this rule number 5, or number 4, number 6. Let's call this rule number 6. Okay. Okay, let's do an integral of e to the x. Well, let's do integration of e to the x, yeah. All right, that will be from rule number, here may rule number, yes, rule number 3. This rule number 3 over here. Okay, let's just apply rule number 3. Let's give some examples on rule number 3 and then maybe Oshira Bambere exam kar give me be 46 rule 1, rule 2, 5 ne mitaw sayo dret mos dia. Push ma kimi be. All right, so suppose the very basic one is what? So basic one, yeah, let's start with the basic. So 42, now 43. So 43. The basic one is if you have integral of e to the x dx, that will just simply be e to the x plus c, just as simple as that. Okay, so what happens if you have this kind of form, integral of 4 e to the x dx? What about this one? So in this case, no. Let's say, let's get e to 3x dx. Let's make it a bit complicated. So we need to let u be equal to 3 of x. Your du over dx is equal to?
3.
3, yes. Equal to 3, therefore your dx is equal to du over 3.
D
Right?
over 3.
Now that you have that, you just substitute it back. Integral of, you take out the constant for integral of e to the what? E to
U.
E to
e to
the
the u times dx, but you know dx is simply du over 3. So you take out the 3, so 4 over 3 integral of e to the u du. But you know that e to the u du is just the same thing as e to the x dx. So that just simply gets you 4 over 3 e to the u plus c. Now you know that your u is simply equal to 3x plus c. And this is your answer. Okay? Now 45. Any questions?
None, teacher.
Okay, what about this one? Integral of e to 2x plus 1. Huh? E to 2x plus 1.
Yeah.
U equal plus 1.
So u is equal to
dx
2x plus 1.
2x plus 1.
plus 1.
Du over dx is simply equal
Du.
to
2.
2.
So dx is simply equal to du over 2.
2.
2.
So integral of e to the u is equals to, so dx is just simply du over 2, right? So I just take out 1 over 2, integral of e to the u du. Now that is simply just e to the u plus c. 1 over 2, e is just simply 2x plus 1 plus c. And that is your answer. Right? Alrighty. All right, that's about the exponential function. That's about the extent of it. All right, let's evaluate the rule. Let's do some examples on rule number. What rule do I get to get you? Giving you an example yet. All right, rule number 5. I think I haven't given you about a lot of examples from rule number 5. Have I? No, yeah, not yet. So far you already know rule number 1 to 6, yeah. 1 except number 5. Now we're going to do rule number 5. So rule number 5 is basically if you have an integral of a number raised to x dx. So 45, now 46. So if you have an integral, let's just start with the simple one. Integral of 2 to the x dx. So if you look at this, our a here is 2, right? So it's just simply equal to 2 to the x over ln of 2 plus c. It's a very simple example. So that is the answer for that problem. Now, what if I have a kind of different kind of problem? Say if I have say integral of 5.5 times 3 to the x dx. So how will I solve this problem then? So I can just take out the 5, integral of 3 to the x dx. Then I just apply this 5, integral of this is simply, integral of 3 to the x dx is simply what? It's just simply 3 to the x over ln of 3 plus c. And that's it. That's your answer. Okay? So that's simply this is the answer. Very simple answer. Okay, so let's do 48. Say I have, let's say integral of 4 of 2x plus 1 dx. What about this one? Now this is a bit complicated, so you need to use the u substitution. So let u be equal to 2x plus 1. What is du over dx?
2.
Just 2. So dx is simply du over 2. So you replace 4 over u times what is dx is simply du over 2. So you take out 1 over 2 integral of 4 to the u du, right? Now you can apply rule number 5. That will just simply be this one. Okay, now you just simply apply rule number 5. That will just simply 1 over 2, 4 to the u. That will just be 4u over ln of 4 plus c. Now you just substitute the u, 1 over 2, 4 to 2x plus 1 over ln of 2x plus 1 plus c. Okay? Questions? Preguntas?
No, teacher.
All right, so let's do more problems. So let's say, suppose you have 49. So let's say if you have an integral of, let's say, x times 5 to the x dx. How would one solve this? No, this is a bit complicated, I think. No, not yet, not yet. Okay, what about this? 49. Integral of 10 to negative x dx. How would one solve this? Okay, so 10 to the x, 10 to negative x can be written as what? 1 over 10 to the x. Yes or no? Los Galay.
Yes.
You can also rewrite this as 1 over 10 to x. Is this the same thing or no? Because 1 over any number is going to be 1. It's the same thing. So you can rewrite this as integral of 1 over 10 to the x dx. So in this case, your a is what? In this case, a will be the 1 over 10 over here, right? And then if you want to apply rule number 5, then your a will just be the 1 over 10. Okay, so that will just simply be 1 over 10 to the x divided by ln of 1 over 10 plus c. Okay? Now, but ihane kan imi bela applicate tam fali logarithmic properties. So shall I? Imi aprendo na logarithmic properties ya sidap. Huh? You should, yeah.
I
In
think,
pre-calculus.
yeah.
You should have learned this. Okay, so
Pretty
you
sure
also
we
know
did.
that this is the logarithmic properties. All right. So if you look at the quotient rule, if you have a logarithmic of something, log of something under x and y, it's just simply of log of x minus log of y. You see? Right? This quotient rule over here. So you can apply that to the one on the denominator. So 1 over 10 to the x is just simply ln of 1 minus ln of 10. That's correct.
Lost teacher.
Yes,
Yeah,
sure.
ln of 1 minus ln of 10 plus c. That will just simply that. Let's see. Maybe tenemos katak on it 1 over 10 to x. The original function is 10 to negative x. So I can just substitute that back. 10 to negative x over ln of 1 minus so ln of 1 is very, very small number. Ya, sama iya calculator. Tatok ln of 1. ln of 1 is a very small number. That's 0. Yeah, ln of 1 is 0. ln of 1 is 0. So you left with ln negative of ln of 10 plus c. So this is your answer. Right? Questions?
No, teacher.
None, teacher.
All right. So quiz number 5. We'll finish with this and then we'll do some techniques of integration next week, and then we go to the definite integrals. Yeah. So let me put up the classes of today. Only quiz number 5. Yeah. So you have about 1 hour.